Well, welcome once again, and I'm just preparing to do a little job for work. And what I've got here is a motor mounting adapter from a marine radar gearbox, and this is actually something using at work. We've got an insect tracking system using 1 centimetre radar, and the rotation rate at the moment is a little too high, so it's running a single phase induction motor, and we want to run it slower, so we're changing the single phase motor to a 3-phase motor running off a variable frequency drive. Now the slight peculiarity of the motor is that it's a NEMA 48 frame motor, so it's an American motor frame. But looking at the specs online, the part number is unique, and part of that is it's a washdown motor. It's a totally enclosed, non-ventilated, with a high degree of environmental protection, you know, so it can be washed down or it can be used in a marine environment. The suffix letters on the frame number were special shaft, special flange. Well, it turns out there's nothing special about the shaft and nothing special about the flange, except that they're IEC metric specification. So, okay, great, we just buy an IEC motor, and we bought a 6-pole motor, which already gave us a bit less RPM than the 4-pole single phase, and all the flanges match up and the shaft's the perfect length and everything else, except that the NEMA framed motor, the bolts go into these threaded holes from behind the flange on the motor, whereas an IEC motor, the thread is in the face of the motor. So what I'm going to have to do is put in a second set of bolt holes from this side so that they can then thread through into the motor frame. So it's a pretty easy job. I'm going to set it up on my mill, centre up on the bore, and just do a really simple alignment of these threaded studs that mate up with the gearbox itself, and then go for the in-between positions. And I know that the terminal box on the motor, there's a lot of space for 90 degrees of positioning where it's not going to interfere with anything else, so that should be just fine. So I'll get it set up on the mill table and we'll take it from there. Okay, I'm sorry about the noise in the background. The fan heaters keeps cutting in, and it's only one setting above frost protection. But very simple alignment, because it's not critical. Just align this block to the front of the table and then use the square off the side of it to get the studs running roughly parallel to the table slots, and the 2 parallels, or they're blocks more than parallels, are sitting in the recess on the back, so I know that they're clear of any of the holes that are going to go through. So the next thing to do will be to centre up and then dial out to the 4 positions. So I'm going to use my coaxial indicator for this, and I've got it set up, and doesn't seem to be very common that people use the little holder block on the side here, so that stops the indicator rotating. And of course the camera's horribly in my way here, as anyone else who's tried to film this stuff discovered. The first thing I'm going to do is just reach up and sweep the spindle by hand and get somewhere within the ballpark. Because one of the things that you sometimes see people do with these coaxial indicators is get them way off and end up snagging the probe tip, and it very easily breaks this joint up here. So I'm actually going to go into back gear. And yes, this isn't a perfect indicator, it's got a little bobble in the gauge, but it's quite good enough for this sort of work. So that was just on the jog speed. So we need to bring the tip out to the point where it's going to be loaded. Bring the table up so we're sweeping the bore. Okay, so now I can actually start the spindle and adjust each axis until I'm seeing the minimum swing on the dial. Shift the other axis. And we're beginning to go up again. Shift back to the first axis. And that's probably about as good as it's going to get. So I can zero the DRO in case I need to move away and come back, and lock the table, and then we'll be ready for the next stage. Okay, we're pretty much set up and ready to go. I modelled this part up in Fusion 360, and you might say, well, it's a simple job, why did you bother? Well, it's documentation, it's a work project. If somebody else needs to do another one, it can go into the project file. So I just did myself a simple drawing. 2D drawings are not one of Fusion's great strengths. In part I can see why, because often you don't ever use a drawing, you're taking the data straight from Fusion to CAM. So I just did something that makes sense to me. So I know that I've got a 130mm pitch circle diameter. So I'll be offsetting 65mm in each direction, and drilling all the way through, clearance for M8, and then counterboring for a socket head cap screw. So there we go. Let's unlock the x-axis and come across. $65. Do a sanity check on position for the edge. Yes, so that's where I expect it to be. And I need to find some cutting fluid. And I can't get past the camera, so we'll use this kind of draper stuff. Let's go back into high gear. That was an 8mm hole, and my cheap Chinese counterbores, which actually work fine and were a very good price. It's an 8.2mm pilot on there, which is rather smaller than the tight clearance hole for an M8. I think they were recommending 8.4. And 8.6 for a normal clearance. So I'm going to drill this 4.2 so that we get a good guide on the pilot. Okay, to get a consistent counterbore depth, I'm going to use the quill depth stop. So there's a 0 on the surface, and I've got my quick quill stops. I've got a stack of these that I can slot in and out. And having set a 0 there, I'm then going to use a 10mm drill shank to give me that extra depth. So let's give this a go. Let's slow it down a little. Oh, okay. I didn't have the chuck tight enough. So let's see what we can do about that. in this case, I'm just going to eyeball 0. Set this once again. One of the problems with the cold is that I'm not getting a very good feel for some things. Okay, and now it's a question of rinse and repeat for the other 4 positions. So there we go, finished result, 4 new holes, all counterbored, ready to put the radar system back together.